So you probably watched the live feeds yesterday, right? I mean, April 6, 2026. You saw Artemis II break the Apollo 13 distance record, pushing out to 252,756 miles from Earth. But today, we're doing a deep dive into the moments the cameras just couldn't quite capture.
Right, because there's so much telemetry and NASA jargon to sort through.
Exactly. We want to cut through all those heavy mission updates to uncover the actual engineering turning points and, well, the human milestones of humanity's farthest trip into space.
I mean, the sheer scale of getting a crew that far out is
Right.
mind-boggling. And then swooping them down to just about 4,000 miles above the lunar surface, that comes with extreme environments we just haven't dealt with in, half a century.
Yeah, and while that distance record gets all the headlines, I'm completely fixated on what they saw on the far side.
Oh, the eclipse.
Yes, a 53-minute total solar eclipse. Pilot Victor Glevin described the sun's corona peeking around the moon as looking like the Luxor casino spotlight. And he said the Earth's shine was literally bright enough to illuminate the moon's dark side.
Which is incredible because the visual contrast out there is so intense that our current digital camera sensors actually really struggle to process it.
Oh, interesting. So the cameras can't even handle it.
Yeah, they get completely washed out or underexposed, which turns out to be a massive advantage for having actual human eyeballs on the scene.
Like sneaking backstage at a cosmic theater, right?
That's a great way to put it. The crew actually used that exact unique lighting to spot tiny meteor impact flashes on the lunar surface, just with their naked eyes.
Wait, seriously? They were just looking out the window and watching meteors hit the moon.
Exactly. Because human eyes handle dynamic range so much better than a digital sensor can. They catch these microstrikes that cameras either overexpose or just miss entirely.
Wow.
And this isn't just cool trivia, by the way. It gives us a highly accurate physical count of the micrometeorite rain hitting the moon.
Ah, I see. So if we're going to build permanent lunar habitats, engineers actually need that exact data.
Right, they need to know exactly how thick to make the armor plating.
That makes total sense. But, while they were out there cataloging meteor strikes, Mission Control was just sitting in dead air.
Yeah, that planned 40-minute total communications blackout.
Right, while they were orbiting the far side. The ultimate isolation.
It really is. But honestly, surviving that blackout was arguably the easy part, because they're currently gearing up for atmospheric reentry at 25,000 miles per hour.
Which generates up to 5,000 degrees Fahrenheit, right? I know this was the biggest engineering anxiety going into the mission.
Oh, absolutely. Especially because of the heat shield cracking on the uncrewed Artemis I mission back in 2024.
Right. I know the shield is coated in avcoat, which is an ablative material that's supposed to safely burn away. But what actually caused it to fracture the first time?
Well, it came down to how the avcoat was applied. It was poured into these discrete blocks, and during the curing process, gases got trapped inside the material.
Oh, so when it got hot.
Exactly.
Yeah.
When it hit the extreme heat of reentry, that trapped gas rapidly expanded and fractured the shield in several places.
Oh, wow. So for this mission, did they just figure out how to pour a flawless shield for Artemis II?
Not exactly. I mean, they improved the manufacturing, sure, but they couldn't guarantee zero trapped gas. So they fundamentally changed the flight mechanics.
Wait, how do you change the mechanics of falling back to Earth?
Instead of a continuous direct plunge into the atmosphere, Orion is executing a skip entry.
A skip entry.
Yeah. It dips into the upper atmosphere, lifts back out into space briefly, and then dives back in for the final descent.
Oh, I get it. So instead of purely relying on the material to absorb all that heat at once, they're using an orbital mechanics trick.
Precisely. You divide the heat load.
It's literally like skipping a stone across a pond to bleed off momentum so it doesn't just slam into the water and sink immediately.
That is the perfect analogy. It divides the heat load into two distinct spikes, which gives the shield a moment to shed thermal energy in between. It's really a brilliant pivot.
It's basically the human element solving a physical hardware limitation.
And that human element is really the core of this whole mission,
Oh, completely. You look at this incredibly diverse crew, which includes Jeremy Hansen, the first Canadian in deep space, and they're leaving a very personal mark up there.
They absolutely are. While they were mapping the far side, they actually proposed names for two fresh lunar craters.
Right, I saw this. One is Integrity, for their Orion ship.
Yes. And the other they named Carol, honoring Commander Reed Wiseman's late wife.
That detail really stuck with me. You have this massive, cold, highly technical endeavor, and right in the middle of it, just a permanent tribute to love and loss.
It's a beautiful reminder of why we send humans and not just probes. Mission specialist Christina Koch summarized it perfectly when they finally reacquired signal after that blackout.
What'd she say?
She said, "We do not leave Earth, we choose it."
Wow. That is profound.
Yeah, it really is.
Well, they are currently coasting back right now, aiming for a Pacific Ocean splashdown on April 10th. But before you go, I want you to think about this.
Yeah, what's on your mind?
Well, NASA is already testing deep space optical lasers. They're preparing to install permanent lunar relay satellites for future Artemis missions just to ensure constant communication.
Right, which completely changes the nature of lunar exploration moving forward. No more dead zones.
Exactly. So that tense 40-minute blackout on the far side of the moon, yesterday might have been the absolute last time human explorers ever experienced true, complete radio silence from Earth.
That is wild to think about.
Let that sink in.